Jaime will be online, but I
you're going
think
to
he
be
will be speaking too much.
Okay.
Unless we have explicit questions.
Right. So the guy is going to be the chair, and this should work, no?
Okay.
After Beyond 2, we're going to speak twice.
This kind of things only happens to me. I don't know how I do it.
There's no regrets.
No regrets.
I want to show you.
They are going to.
Oh, fantastic.
This one. But that's finished.
This is Beyond 2.
We have now Alma, who is here in person, and she's gonna talk about cosmology and the dark energy spectroscopic instruments. All right, so thank you, Alma, and the floor is yours.
Okay, thank you very much for organizing this this symposium. I think it's a really good way of discussing the science that we are doing in Latin America. And so in this first talk, I want to talk about the dark energy spectroscopic instrument and its extension. And this was a white paper that was actually an initiative from Jaime Forero-Romero from Colombia. And well, at the end, we decided that I could present it because I'm here in person, but I believe he's online. So if at any point there is a comment or a question that he might address better, I would give the voice to him, okay? So first, our typical acknowledgements to our sponsors, but in particular, I want to highlight the different institutions that are part of DESI that are in Latin America. So we have Universidad de los Andes, the Universidad of Guanajuato, where I come from, and UNAM, ININ, and Simstaff, and different institutes from UNAM are part of DESI. So what is DESI? Yeah, I'm going to talk very briefly about it because probably you all know about it. So this DESI is an experiment that is running already. It started in 2021, and the aim is to get the spectra of about 40 million galaxies and quasars in a span of 5 years. The main scientific goal is to measure the expansion of the universe through cosmic history. So we are measuring it at different red spins. And the main techniques that we are using are the baryon acoustic oscillations and the redshift space distortion. Of course, there are other techniques that are being under development and that we hope that by the end of the 5 years will be mature enough to get even more information. But the baseline techniques that we are using are these BAO and RSD. So apart from investigating dark energy, which is in the main name of the experiment, there are other goals regarding dark matter nature, measuring the neutrino mass, and understand or exclude or includes modified gravity, etc. So this instrument is installed at the 4-meter telescope in the Mayal at the Kitt Peak in Arizona. As you know, one of the highlights is that in the focal plane, we have these 5,000 fibers that can adjust their position to new targets very quickly. So we observe a field of view for around 15 minutes, and then we can change very quickly to another field of view, and it reconfigures in a couple of minutes. Okay, so the field of view is about 80 square degrees, and during this 5-year survey, we expect to cover 40,000 degrees. The light we receive from our targets goes to the 10 spectrographs that are covering this range of wavelength. Okay, so you might have heard or saw the announcement that this year we released our first cosmological results. And this is just like the money plot of our results. So what you are seeing is basically the expansion of the universe at the 5 redshift bins that we are measuring with DESI. The first 4 are with galaxy and quasar tracers, and the last bin, the highest redshift bin, is with the Lyman alpha forest. That is the actual spectra of the most distant quasars. So the main conclusion that we got is that while the lambda CDM model is still a valid interpretation of our data when we assume that is the underlying model, if we give some freedom, the data prefers to have a equation of a state that is evolving with redshift. W0WA is a model that we have used, and using DESI data in combination with different supernova data sets, all tends to prefer this more flexible model. Of course, for now, this is only a hint. For now, this is not called a detection, nor a strong evidence or anything like that. We need to gather more data. This is just the first year. Yes.
What is the difference between the top and the bottom plot?
Yes, it's the distance. It's the top is the ratio of this DV distance, and this is the Hubble distance. It's just the ratio of the two distances. The one above is with respect to the BO scale that you put as a fiducial value. It's just the distance you use to measure it, but the conclusion is the same. Yeah. I was saying, yes, this is just a very first hint. It's nothing set in stone. We need to look at the data for the next, for the coming years. And we are actually now starting to analyze the third year of data. So these results were presented and summarized in this set of papers, and this is a nice diagram that Gustavo Nis made to guide how to read or how to go through all the results. And so the data is going to be published in that data release of year 1 that is not yet out. So year 1 data is not yet public, but is all the data that we use and that will become public probably early next year. From this, we have on April 6th, we put out 2 main papers. Three main papers. The two first measuring the correlation functions with the different tracers. One for the Lyman alpha forest and another one for the galaxies and the quasars. And those 2 measurements went into the cosmological interpretation that gave rise to the previous plot. And these papers are accompanied by a long set of supporting papers where we actually present the details of the measurements, systematic analysis, studies of contaminants, and so on. So what I want to highlight with this slide is that all these blocks in red are marked because those were led or have a very significant contribution from members in Latin America. And as you can see, it's a very important participation of our community. There is another 2 sets of supporting papers that came out later, and also you can see the Latin American presence very well in there. Okay, so what is our role and what is our community? So basically, we have divided it in the Mexican participation, the Colombian participation, and some members that were previously formed in Latin American institutions or that somehow are related to them. So in Mexico, the Mexican participation is present in DESI since 2011. with Axel de la Macorra and Jorge from UNAM and Jorge Cervantes from ININ. They were both pioneering the effort to get a Mexican participation in DESI. They were both involved in the DESI planning, actually. So those white papers that you might have seen from these years, they were involved in that. So in 2015, they two, together with another set of researchers in Mexico, got CONACYT to sign up an MOU to support the Mexican participation. And the current participation is basically involving 4 main institutions that I mentioned earlier. And in total, there are 8 full participants and about 26 sponsored participants. I don't have to go into it. I don't want to go into details of that, but you can see here the list of all the people that is involved. So you can see it's not a negligible size of a participation. The main science and interest and contributions that the community in Mexico is working on are related to the actual measurements. So we have people working on the galaxy, BIO and RSD correlation function measurements. And we also have measurements on the Lyman alpha side. And I can say that is mainly the work at the University of Guanajuato. Of course, there is also people involved in the cosmological interpretation of these measurements, both in the lambda CDM model and non-lambda CDM. So we are interested in contributing to the main goals of the CSA collaboration, but also we are exploiting the data to their own models that we have in our Mexican community. There are other topics where some of the DESI members in Mexico work on, such as galaxy clustering with full shape modeling and different compression techniques that, as I said, they are not the main or the mainstream measurements that we are using now, but we hope that by the end of the survey, they will be used. We are looking, or people is looking at higher order statistics in galaxies. All the above is 2-point correlation function, but we know we can extract more from 3-point, 4-point, and n-point correlation function. There is a group working on the Milky Way survey that is going to take actually a great relevance in the forthcoming years to understand dark matter, for example. And there is efforts to measure the effective number of species or the neutrino masses. And of course, we're very interested in the LSST and the DESI synergies. That was in terms of science, but we have done a lot of contributions in terms of infrastructure and operations. And this is just a list to mention some of the roles that people in Mexico have taken. So Axel is a voting member of the DESI institutional board. Not every institution have a voting member in this institutional board, so this is a good thing. There are other members of the institutional board, as Gustavo Nis, and actually Jaime Forero is also a member of the institutional board. Gustavo is the chair of the publication board. Mariana has been chair of the meetings committee. I was chair of the working group in Lyman Alpha and one of the co-leads of the year 1 Lyman Alpha key papers. Our juniors are also involved in these tasks. As Andrea Munoz, she was chair, and actually she promoted a lot the creation of the early career science committee. And well, you can see meetings committee, publication board, outreach committee. So we are everywhere, basically. And I forgot to mention, but all this work has granted status for 3 full participants and 2 sponsored members as builders, which is the highest recognition that one can get within the DESI collaboration. Okay, so that was all about Mexico. So for Colombia, as I said, Jaime Forero, he's from Colombia, and he's the only full participant from this country. But he was also very highly involved since DESI design and planning. He also is a member of the institutional board, and he's also a builder. I can say, because I have seen it with my own eyes, that he has been really active in the data management and the survey operations team. So his work has been instrumental. He has sponsored several members, several junior members, and I'm happy to say that one of them, John Suarez, is moving to Mexico to a teaching position at the Tec de Monterrey. I had the pleasure of working at some point with Luz Angela and had discussions with David Sierra as well. So they are also very active in the collaboration. They, as a team, have focused their participation in the building of software infrastructure, as I said, for the data systems and the survey operations. I will not go through the list, but you can see that they have worked in different aspects. In fact, for instance, for the Lyman alpha measurements, they were working together with us to create more realistic data sets and actually to take into account or to use our simulations to try to see the impact of decisions that we were making on the reobservation of quasars for the Lyman alpha science, but by considering the observation strategy for the full DESI survey. So we have had collaboration with him. As I said, there are other participants from a Latin American background that are spread along the world, and this is a probably not complete list, but some of them, most of them have done their bachelor's degrees in Latin American institutions and moved to a US or Europe institution, and now are part of DESI. A few of them actually got their PhD at Mexico or in Colombia, and now are getting postdocs outside. So I think that's also a very good thing as a collaboration. So of course, there are members that have retired, and here what I want to highlight is that to our knowledge, people that is retiring is not because of there is no work to do or not perspective of work to do in DESI, but is because they are changing of institution and the new one is not part of DESI. They change their research interest or even their career path, but we know at least a few people who have actually gone into the data science workforce kind of straightforward. So this is just a plot that I could manage to get from the ADS publications, just to highlight that. So in the circle on the left, you see a lot of names. And in principle, it represents how the DESI collaborators are interconnected between each other. And if the name is in a highlighter and you can read it, it's because it's very interconnected with all the others. And you can read Jaime Forero names and Mariana Vargas, for example, in there. Mine probably is not there, but I think it's interesting because this means our participation in DESI is visible. You know, it can be highlighted. I also got a few numbers. So in 145 of 195 papers submitted or published in DESI, there is at least one senior researcher present in them. So it's a lot. And there is about a dozen of papers signed as a primary authors, meaning not just in the alphabetical list, but as a primary authors, with a member affiliated to a Latin American institution. And this is not trivial because DESI has a very clear and strict publication policy. And I want to end this session with talking about our outreach efforts. So we have a program that is called DESI Hive. There is a set of notebooks where we show the DESI science and the access to DESI data for high school students. And this initiative was originally in English, but we have the full set of things in Spanish as well. And we have run many workshops with high school students, both in Spanish and English. And our next event is gonna be in Chihuahua for the National Conference on Physics in Mexico in October this year. And also because we have this important Latin American community, we have the DESI web pages translated into Spanish and Portuguese. And the translation was done basically by us, the scientists. It was not done by translators or artificial intelligence or anything. Okay, so let me go back to DESI and tell you a little bit about the goals for the next years and the timeline. So as I told you, the goal is to get about 40 million redshifts in 5 years. We completed the first 3 years, and we are now taking data for the last 2 years. So we are analyzing the third year data set, but the instrument keeps getting data very quickly. So in the right, you see this map where red means the area that is more complete, that has been a good coverage for the DESI survey. As you can see, most of the regions have been observed. There is a small patch that still has to be observed, but we are progressing very well. We are there in 2024. We have put out the year 1 results. We have the year 3 data sample almost ready for final analysis. And there are 2 more years of taking data that will call it the end of the survey. And of course, we need to do the analysis, but the interesting thing is that there is most likely to happen a DESI extension and most probably also a second phase of DESI. So what are the science drivers for the extension? First is to actually go after the dark energy nature and try to see really what is driving the cosmic acceleration. In the main goal of the original DESI, what we want is to measure the expansion rate, right? But now it's okay, we now measure this, but let's go after what is driving this expansion acceleration. We also want to enhance our ability to discriminate between models, especially given these hints of time evolving dark energy. So we need to go after it. And we want to maximize synergies with other cosmological proofs, including with lensing, CMB lensing, and galaxy-galaxy lensing. And we are ahead of schedule. We are almost 6 months ahead of schedule. So why not extend it a little bit more? The current plans is to extend the operations by 2.5 years. That means the survey will end at 2028. And this means expanding the footprint for 40,000 square degrees to 17,000 square degrees. We will add more 2 more dark passes and 1 more bright time passes. That means for the quasars, for example, that means we reobserve more times the high redshift quasars, and we get a more complete selection of the LRG and the ELG's targets, as you can see there in the percentages. This is an example of how the DESI footprint will look like with this extension. And in red is where it will overlap with LSST, for example. So by extending the survey, we can extend the overlap with LSST, I think it's by a 50%, it says over there. And instead of around 40 million, we will get 63 million redshifts. So the measurement, the variance on the BAO measurement will increase by about 20% across all redshifts. We are still assessing the impact on Lyman alpha science. I mentioned that because that is where I work on, but it's almost secure that this is going to happen. We are just still looking at what is the gain that we will obtain. But there are expected challenges if we go with this extension. The first one is that we need to maintain the instrument performance for this extended periods. We have to ensure the good quality of the spectra now that we will be observing at a higher mass. And there is some data volume and computational requirements, and all of this means money, about $30 million in additional funding for these 2.5 years. For the LATAM community, this doesn't mean too much because it will not cost most our participation. Or buy-in or existing buy-ins will cover this extension. But of course, it will mean we need continuous funding to maintain an active participation during these 2.5 years. And of course, we need junior members to keep joining our groups so that we can keep on with the work pace. And My final slide is about how I think, and I discussed this with some of the members of Mexico and with Jaime, how we can increase the Latin American impact on this. Well, first, there is a lot of people, as I showed you in the slide, that is abroad from a Latin American background. So we should start thinking on how to retain them or bring them back to LATAM so that they continue with us. New buy-ins could be desirable, but I don't think it's a priority because they are expensive, but it's possible and it will be desirable, especially maybe for countries or institutions that are not yet part. But more important, there is a figure of external collaboration. So if there are topics of interest to Latin America that are not covered or not of a lot of interest to the DESI members, then we can apply for external collaborations, and they are usually well received. We need fund mobility because even we have strong groups at home, and as you have seen, we have done a significant contribution. What we are doing a significant contribution, it is always good to interchange knowledge with our partners, and of course, that our students face international competition so that they can get jobs, basically. And to make our work visible. If we don't attend to the meetings, then people don't know what we are working on and the impact we are doing. And for me, it's very important to transfer the knowledge. I think this is something we have to pay a lot of attention in the forthcoming years. We have to prepare non-DESI participants to make use of the public data that is coming out. And well, the outreach programs is very important as well. Thank you.
Thank you, Alma. Are there questions for Alma from outside? Or maybe from here? Martin?
Yeah, I was in the previous slide, I was curious to see, you referred to the DESI bylaws. Is that for, as like a minimum salary?
Sorry?
What do the DESI bylaws say?
It was just to set a reference for where this number comes from. So to the buy-in, to become a member, a full participant member of DESI, you have to pay a buy-in of $250,000 for one single person. And that includes the full participant and the students and the juniors. So that is not cheap, it's expensive, right?
It's for good. It's not
It's an entry fee.
Yes, it's one buy-in fee and that's all.
That's all.
And it includes juniors as postdocs, students, and so on. And I just wanted to mention where you can find this information because there are other subtleties. Sometimes you can get some discounts and, you know, if you're interested, this is the document to look at. But I will, for example, I will recommend a lot to look for external collaboration. There is a lot of topics that there is simply not person power within DESI to exploit the data. So we can take advantage of this kind of things.
Anyone else from outside? Here? If not, let's thank Alma again. And next is Rogerio. He's gonna tell us about LSST in Latin America.
Right. So thank you to the organizers. No.
You got yourself.
Very successful conference. Has to be attended. So okay, I'm going to talk about what is happening with the legacy survey of space and time, that's LSST, in Latin America, since the first strategy. So this is an update of our white paper that we submitted back in 2018. And there are many people that were involved in the white paper. These are just a few of the people involved, and Alma is here. It's one of them. So this in the background, of course, is the Vera Rubin Observatory, and I have more pictures to show about that. And yeah, sorry, I have things of DS also because I'm a member of DS, so I decided to put the DS. and also this desk. I'm going to explain what desk is, and I'm part of Linea, and we're supported by an ENCT, and the same thing that's supporting the LHC experiments, and we also want to have an IDAC. I will explain all of this as we go along. So what are we doing? What do we want to do? So what we want to do is to test a cosmological model. So we have a consensus, a standard cosmological model, which is called lambda CDM. And this is amazing. It's amazing because it can explain from the very early stages of the universe to the more recent stages of the universe. It's the same model. And we want to check the consistency of this model across these different times in the universe. So we are here. We want to look at galaxies that have appeared in the few billion years in the past. Now, there were no galaxies before, of course, and we want to see the consistency between the distributions of galaxies, the numbers of galaxies in this lambda CDM model with the measurements in the cosmic microwave background that's very precise. Okay. So talking about galaxy surveys, so the LSST is a galaxy survey. I just want to mention there are two main types of galaxy surveys. One is the spectroscopic galaxy surveys. That's what Alma mentioned about DESI. DESI is a spectroscopic survey, meaning that it takes a spectrum of galaxies to really see the light of each galaxy. So it means that you have access to very, very good measurements of the redshift. And however, you pay a price because you have to know where the objects are beforehand to put fibers on top of each galaxy. So there are 5,000 fibers, as Alma explained, and they also they don't have the image of the galaxy. They just collect the light. But however, the redshift information is incredible. The other main type of galaxy survey is what we call photometric surveys. So these are imaging. So what we do is that we go to a field in the space with our telescope and we take pictures. And then we see what's in there. So we don't need to know where the galaxies are beforehand. We find them. Actually, I think we can provide targets to that's one of the synergies between the two processes. So this is great. So we have a large number of objects. So Alma mentioned, 60 million galaxies. With DS, which is DS is dark energy survey, is the precursor of LSST. We already have 300 million galaxies. Just to give an idea. 300 million galaxies.
What is the total number of galaxies in the known visible universe?
A few billion, 10 billion, 100 billion. So one day, we're going to find all of them. No, LSST is more, they don't find galaxies. They have to know where they are, right? Why? Because we put the fibers in each galaxy, top of each galaxy. We don't. Just take pictures. Then say, how can you measure redshift with pictures, right? With photograph. Well, first of all, yes, so it's not what we do is we use different filters. So it's a very, very poor spectrograph. Because we have the light in 6 different filters. And from that, you have to estimate the redshift. The estimation is non-trivial. There are several algorithms, artificial intelligence, for instance, the magic word is used for this as well. But there are several algorithms to do this. And it's a fair quality. It's not, of course, it doesn't compare with spectroscopic surveys, but we do have estimates of the redshift. And then we have a large number of objects, and we have images of each galaxy. We have a picture, right? So we have the city galaxy. And that's important. And I don't know I'm going to say that, but it's important because if you have matter between you and those galaxies, the shape of the galaxies will change due to gravitational lensing. And this is an important information.
Also, if the galaxy turns around, then the red shift different on one side.
You know what's the time scale for but a galaxy that we're seeing is like a pixel, right? Or 2 pixels. You don't see that. And then we see the small deformations in the shape of the galaxy. So for the redshift, it doesn't matter for us, right? Our uncertainty redshift is large compared to this very small rotation. And then you're seeing galaxies very far away. So this effect is very, very small. Yes, okay. So just to say that dark energy survey and LSST are photometric surveys, whereas DESI and SDSS, maybe you have heard of this before, Slow Digital Sky Survey. There are many letters, sorry. They were all spectroscopic surveys. So this is a timeline. This is from the report of the topical group on dark energy and cosmic acceleration of this NOMAS effort. So you see where Rubin is, and you see where DESI is, and DESI 2 is already here, the extension that Alma talked about, also LIGO and CMB, etc. Just to see where we are. So we're planning to start, I tell you, in 2025, and it's a project that's going to run for 10 years. Yes. Of course.
You distinguish to me the difference between the LSST and the
Yes. Very good question. So wait a second. I tell you exactly the difference. Very, very good. So, so this is the P5 report that we heard from Hitoshi in the second day. And he didn't mention the first recommendation because it was so obvious that he didn't mention. But I have to tell you because, you know, the Vera Rubin guy, so that the Vera Rubin Observatory that will carry out the LSST survey is one of the main recommendations of the P5 process. But specifically to look for dark energy. So the dark energy science collaboration, and I have to tell you what dark energy science collaboration is. It's coming. Yeah. Yeah, so what I want to say is that this is DOE, and DOE finances part of LSST, especially the part that relates to dark energy. Now, so the dark energy science collaboration also has dark matter in it. Okay, so now I hope to answer your question. What is the legacy survey of space and time? So the LSST is a 10-year survey to be conducted at the Vera Rubin Observatory. So it's a survey of observatory, okay? Vera Rubin is the observatory. So the telescope is the Vera Rubin, the telescope, the telescope has a different name. This is the Simony Survey Telescope, because Simony is the guy that donated the money. Actually, Bill Gates also donated some money, but he didn't want his name. But Simony is the mirror, is the telescope that donated, his guy donated money. So the Vera Rubin is the observatory. The telescope is called Simony, and the project that's going to be conducted in this observatory for 10 years is LSST. After 10 years, it's not going to be LSST anymore, unless there's an extension, etc. Like dark energy survey. Dark energy survey took data for 5.5 years. Now the instrument is still there. The camera that was built by the telescope is still there, but it's not dark energy survey anymore. It's for the community, actually. Community can use it. Okay, so that's what it is. The telescope has 8.4 meters. It's primary mirror. There are 3 mirrors, and the field of view comparable to DESI, 9.6 square degrees. It's like 40 full moons. And so I told you that we take pictures. So we're going to take pictures with the largest ever digital camera view. It's called LSST camera. It is. It doesn't look much, but it is.
About the LNC.
Huh? We can talk about this. So they have special CCDs that they have to measure light, etc. with different filters. Anyways, you tell me how much. Okay, we can compare. So this is 3.2 gigapixels. It's the largest. I'm sure this is the largest. It's really big. I'll show you a picture.
It has some. Sorry.
Okay. Okay. So so we're going to take pictures in 6 filters. Those are the names of the filters for those that UGRIZ, it doesn't matter. 189 science CCDs. So the construction started in 2015, and the idea is to start data taking in 2025. So 10 years of construction. The project started much before. Now the planning and said the construction started in 2000. I showed the fundamental stone. Is it how you call it in English? Pedra fundamental. The first stone. Huh?
Yeah.
First stone. You say pedra fundamental. First stone. Okay. So again, this is just to show you the amount of data that's going to be collected. So actually, so since we take pictures of the universe and we don't have to see where the, we don't have to know where the sources are. We actually have to have a film of the universe because we take pictures every 30 seconds. We take pictures, so we know it's a movie, right, of what's going on. So it's very good for transients. So there's lots of physics you can do in the LSST. It's not only dark energy. I show you what. This is just to show different what we do. So raw data is 20 terabytes of data per night. We're going to issue 10 million alerts per night of energy to other telescopes in the world. So if we see something that happened, like a star exploded or an asteroid or whatever, we send a alert. So there are brokers, they're called brokers, that these are the community brokers that we look at these alerts and follow up spectroscopically. Doesn't matter. So also important is that the computation is going to be done by some central data access center, but also independent data access center. And we have some proposals in Latin America for that. So the science, there's a lot to do. It's much more than dark energy. There's an unprecedented amount of data, and there are multiple science goals. Some of them are described in this LSST science book, is already a bit old. Actually, this can be confusing, but LSST used to be the Large Synoptic Survey Telescope, and then it changed its name. So now it's the Legacy Survey Space and Time. You can see that this is still the old one. And the science topics are addressed within what is called the LSST science collaborations, which are autonomous and self-managed teams. And there are 8 science collaborations. This tells you the broad scope of the science of LSST. So from active galactic nuclei, dark energy science collaboration is the largest one, more than 1,000 people. So we're talking about 5,000 people in total. Informatics and statistics, that's where artificial intelligence is developed. Transients and variable stars, looking at stars in the Milky Way, local volume, strong gravitational lensing, galaxies, and solar system also. So asteroids and things like that. Everything. It's everything you can do. So LSST in South America, in Latin America. So currently there are 4 countries participating in LSST. And I put them in temporal order where they joined. So Chile, Brazil, Mexico, and Argentina. And the joining of Mexico and Argentina is new. So something that happened after the first, this is important. So I'm not going to go through this, but Chile, of course, is the host country of the Vera Rubin Observatory. So any astronomer in Chile has the rights to join the Vera Rubin, and also so the Chilean community is granted 10% representation in most of the Rubin scientific and administration committees. They also have some money that's so it's called Rubin Chile Fund that comes from LSST. And in addition, ANID is supporting some 3 large centers for LSST related sciences. So I'm not going to go through this because this is in the white paper. Also, Brazil joined LSST in 2015 under the leadership of this Laboratório Interinstitucional de Astronomia and the Laboratório Nacional de Astrofísica. And there was an agreement that was signed with, including FAPESP, where is it, and the Rede Nacional de Pesquisa, that secured the participation of 10 principal investigators in LSST and 40 junior associates. But recently, in 2020, this year, an agreement was signed between Linea Association and SLAC that secured additional 16 PI position through an in-kind contribution. And one of the in-kind contributions, in addition to the development of photometric redshift software, is this independent data access center. So at the moment, there's a Brazilian participation group at LSST. I'm the coordinator. There's also funding from ICTP, so Instituto Nacional de Ciência e Tecnologia, the same thing that supports CERN, the CERN Brazil. There's one for LSST, and I'm the deputy coordinator, and I'm the coordinator of the Brazilian participation group that has more than 100 participants from 26 institutions in Brazil. And there are now currently 23 principal investigators that are involved in the dark energy science collaboration, the active galactic nuclei collaboration, the solar system collaboration, and Milky Way, and informatics and statistics. We published article in the Revista Brasileira de Astronomia about LSST. So the Mexican participation started in 2020. It's coordinated by LSST Mexico, which is a consortium, and they have it's an in-kind program, PI slots and associated juniors. But you see more in another talk by Alma. Argentina has joined in 2021 through in-kind contributions also. And they have 12 principal investigators and 48 juniors. They're involved in several science collaborations inside LSST as well. So we recently organized the first meeting, Latin America meeting of LSST. So LSST, there's something going on in Europe. This is the 6th edition this year, LSST at Europe. There's LSST at Asia, and we decided to organize LSST of Latin America. So Alma is one of the organizers as well. So these are the institutions that participated. Was hosted by University of La Serena. And this is a nice poster that was designed by one of the organizers, Yasna Ordenes. So this happened a couple months ago in La Serena. So La Serena is very close to where LSST is, where the Rubin Observatory is, which is in CTIO. It changed its name, not CTIO, of course. Okay, it used to be the Cerro Pelon International Observatory. So we went there during the conference. It was very nice, and I think I have a few pictures. So this is the LSST now. It's pretty much finished, and this is the telescope. You see the back of the telescope, and this is the primera piedra, first stone. Yes, 2015. Can see here. So that's where it started, and this is the this is where the mirror is. Actually, the mirror was recently, this is what is showed me, right? The mirror was recently removed from this, was coated. The mirror is a whole story. It's amazing. This is amazing mirror. It has 2 mirrors in one, but I can tell you this later. And this is the, it's not the real camera. This is the commissioning camera that is going to be put in the telescope just to see how the optics work. The real camera is inside here. It was shipped from Slack last year. Last year? It was December, I think, that arrived in the mountaintop. And this is a picture of us. So there was a workshop, but I have to say there was some floods during the workshop, so we couldn't go to the university anymore. So we met in this room in Aura. So Aura is the company is what runs the observatories. The headquarters in La Serena. This is Holger. That was one of the organizers. This is Yasna, and you can recognize who this is.
Is it at high altitude?
Huh? No, this is sea level.
Sea level?
This is sea level. And this is 2,000 meters, not very high. 2 minutes, 2 minutes, yes. So we had also a workshop in Brazil about community brokers. I told you about these millions of alerts. They have outside of the collaboration, what's called brokers that receives these alerts. So we had this one called Think, and Brazil is involved in this. And also there was a teachers online workshop that Fernando Licio, the liaison of Rubin Education and Public Outreach in Chile, organized together with Alma. We had the high school teachers from the region, 100 participants. And to finalize, I just want the major updates since the last, or the first, the first strategic planning, that Mexico and Argentina join LSST. This is a major thing. This first agreement, ICRADA, that was signed with Brazil in 2024, this year. We had the first Latin America meeting just for LSST this year. The first photon with the commissioning camera is imminent. So the idea that this commissioning camera will be, the commissioning camera has the same dimensions as the final camera. But the idea is to test the telescope and the optics and everything. And we call this the first photon that will be detected. So this is imminent. And first light, when really things will start working with the real camera, which is called the LSST cam, is in 2025. That's it. Thank you.
Next, Rogerio, are there any questions for Rogerio?
Yes.
What would you say should be your priorities as a Latin American?
I think we should continue getting to know each other and try to have common goals and organize ourselves. And we should try to be more effective in organizing, in focusing in the same teams, for instance. That's a possibility. Yes,
Let me ask a provocative question.
course.
So I remember that.
I wouldn't expect anything less from you.
I remember that when Roger started,
Yeah.
CBPF or Brazil, not through CBPF, I think Scheller was quite keen on that,
Yes.
made an effort of making sure that through Brazil, for example, Bolivia would participate. So Brazil was paying for Bolivia to participate.
Right.
And well, one can argue how much effect it had,
Yes.
etc. But for a long time, Bolivia was part, and of course there is a tradition of cosmic rays there. So
Yes.
I see that there are many Latin American countries that participate through their in-kind contributions.
Yes.
But has it been discussed of the possibility of these countries getting together and, or maybe some of these countries that have more resources, paying the way for or opening space in their quotas for countries that don't have access?
That's a good thing. I don't think it was discussed. I think that once I had a crazy idea, my crazy idea didn't go through. My crazy idea, I can tell my crazy. It's recording, I can tell my crazy. As I said, Chile is a member, and anyone that's in Chile can be a member, right? So my crazy idea was to have.
To become Chilean.
I should.
We all become
Have
Chileans.
joined association with Chilean institutes of people that are interested in joining. But that didn't go through. It was too much. No, it was too much of a Latin America. I don't think. So yeah, so for instance, yeah, I can see that happening, but at the moment, for instance, we completed our quota.
I imagine the internal competition for the
Yeah.
limited places is large.
Yes, yes, unless we make a reservation for. Also, we have to see if there is interest from other countries.
Yes.
In Colombia, of course, there's Jaime, and that there will be a natural person to join.
Because of course, the hope, and I guess that was the argument at the time it was proposed for Roger, is that you maintain a key group of people that could stay there for a few years, several years, a decade. And then they nucleate something in their country, then they move autonomous, right?
Yeah.
After.
So that's going to be possible, yes.
Can I comment? Yes, actually, the in-kind programs for each country allows for it. It doesn't prevent that we can support another participant that is from another country that doesn't have their own in-kind contribution. So it's not like explicitly written,
Yes.
but it's not forbidden in the agreement. So in Mexico, we have not discussed that in detail, but we are kind of open that
Yes.
this might be a possibility, especially, well, in our case, especially for Mexicans that are in other parts of Latin America that could contribute and to be a way of collaborating.
Yes. And there's another thing that Alma mentioned in her talk that we also have here in LSST, the external collaborators. So what is an external collaborator? So suppose you have a special talent, you can do something that no one else can do in the collaboration, right? So you can apply to be an external collaborator to work in that specific topic.
Right.
And that's usually welcome. Okay, as Alma was saying.
One other thing that is important is that each science collaboration has its own rules
Yes.
for the publication policy. And
Each
there are
of those AGMs.
Exactly.
Yes, they're independent.
dependent, and each one has defined or is in the process of defining its publication policies. And some of them, and I think that is the case, it's not against collaborating in a particular project. What the data rights from Rubin means is that they don't have direct access to the data, but people can contribute to the analysis, assigning theory or whatever. So there is
Right.
actually a quite open collaboration for external collaboration.
Yes, but again, this is for the dark energy science
Yes,
collaboration.
each
The others,
collaboration
they're
is,
still working on their,
So you only have Latin American countries. You showed 4 countries from Latin America.
This is from Latin America. No, this is an international collaboration.
Okay.
It's led by the US.
Okay.
So actually, it's led by, this lab.
So your in-kind contribution, does it mean some hardware?
So the in-kind contribution can be hardware.
It's built already.
No, but there are things like the software is still needed.
Right.
So, so we are contributing, for instance, for the photometric redshift effort, and also for computing. So IDEX, and also Argentina has offered some telescope time for follow-ups. You see a transient, you can go to use this time in telescopes in Argentina. So things like that. Mexico is probably the IDEX. To talk about it.
And unless there are any more questions, like a very quick one, we'll move on to, again, Alma.
Again.
Gonna tell us about the same experiment, but from the Mexican side specifically.
hello again.
Yeah, of course, I didn't have time to go in detail. There are hundreds of people working in different topics in all this science collaboration.
Okay. So I will not go again over what is Rubin. I will just talk about the Mexican participation. But I want to start with this slide of what are the main science drivers on Rubin or the LSST. And as you can see, it can be split in 4 broad groups. The first one is about dark matter and dark energy. And it's important, as Rogerio mentioned it, that this appears explicitly in the P5 recommendation, both dark energy and dark matter. And by the way, not only for Rubin and LSST, but also the DESI extension and DESI phase 2 were mentioned in the P5 report. One of the other goals is to make an extensive inventory of the solar system. They want to map in great detail our Milky Way. And as Rogerio mentioned, it's a very good experiment for exploring the transient sky. So the Mexican participation in Rubin has been through a long road, a bumped road. We started actually in 2015, maybe even before that, but we started in 2015 looking for funding to join. At that time, being part of Rubin for LSST was $40,000 USD per participant, per senior researcher, and it included the participant of 4 juniors. So it was quite expensive. After 1 or 2 years, I think it doubled the price. So that was unsuccessful, and we were almost throwing the towel until in 2019, LSST changes the way to enter the collaboration, and they sent the in-kind projects. So we made a proposal in 2019, and it went through a process to be accepted, and we finally joined it in 2021. That means in 2021, we started to define the in-kind contributions details, right? But for example, the agreement is still in process of signature with the DOE. Actually, just yesterday, I knew that we are almost there. Yes, we were waiting for the approval of one of the institutions, and we have it. So Octavio Valenzuela, who is at the Institute of Astronomy at UNAM, and myself were putting together this proposal and getting other researchers interested in it. And at the end, together with Luis Ureña, also from Universidad de Guanajuato, we put this proposal for getting data rights of 20 principal researchers in exchange of six in-kind project contributions. And I'm going to tell a little bit of more details. All of our contributions are mainly software development and one light IDAC, that is a computer resources, basically, storage and computing resources. You can see the list, the full list of data right holders in that web page. So we then, once our proposal was accepted, we created this consortium, LSST-MX, that is meant to support the in-kind program, but also to take care of extended it to other institutions to give some support to the scientific activities and to foster collaboration, not only within the members of LSST-MX, but with other researchers across the country. And in particular, we are very keen to make this transfer of knowledge in general, because Rubin's data is going to become public after 2 years of proprietary time. So there is going to be a wealth of data available for everybody to work on it. So we need to prepare the community for that. So we signed a collaborative agreement between Universidad de Guanajuato and UNAM to create this consortium. And so these institutions are the ones that are providing all the legal and institutional support before the OE and SLAC. The participation and the data rights on Rubin are overseen and evaluated annually by LSST-MX through a membership committee. That means that no one in the Mexican participation has a permanent and forever position. We are really interested in making the most out of this. And we really want to have people that is actively working on the collaboration. Right now, we have about 14 participant institutions. I list them there. We perform monthly meetings to share progress, report activities. There is a lot of bureaucracy sometimes, and people wants to go more into the science, but all this work that we are doing that looks very managerial is really necessary for us to be part of Rubin. So we cannot leave it behind. And I think it's important that we are trying to set very clear rules of how we are managing the use of the licenses, who gets data right access and who doesn't, and for how long, and so on. Because we have a limited amount of slots, so we want to exploit them as much as possible. That's the philosophy we have. About funding, everything has been run through individual grants from CONACYT. Was there a question?
Who's the LCDB?
Jorge Mastache in Chiapas. He's a theorist. Okay, this is the full list of members, including juniors and some technical staff, and it's about 50 people right now, and the list of institutions. So our participation is spread into the different science collaborations, and basically to each of the science collaboration, we have an in-kind contribution to it. One important difference for our in-kind with respect to others, including the Brazilian one, is that our in-kind is being paid directly by the researchers who have the interest in being part of Rubin. So we are, in some cases, we are hiring specifically people to do some job, even if they will not be permanent in that position. But most of the contributions are directly paid by the one who wants to belong to Rubin. So, and that has some advantages and disadvantages, but so far it's kind of working. Okay, our current projects, our in-kind contribution is, the first one is directed to the strong lensing science collaboration. And it's a directable software development. What it means is that it's a science collaboration who tell us what are their needs and what they would like us to develop that is helpful for the science they want to do as a collaboration. And so in this case, what we are doing is to create tools and to design metrics to identify how well or how good are the Rubin images for early lens detection purposes. So Rubin is going to provide us with already coated images, but after some time, right? So what we want is to identify early on the images that are good quality, and stack them on our own to maximize the lens detection. So right now we are just working with simulated data and looking at different ways of coding these single visit exposures into deep coads. But there are other non-in-kind activities. So we are mixing up the work that we do that counts as an in-kind with other works that are just the science that we want to exploit. So in this sense, there is people working on strong lensing modeling with action-like dark matter models. There is people working with artificial intelligence to estimate time delays. And there is people working with machine learning techniques to detect the strong lensing systems. And this is just some pictures to illustrate the use of the structure, right? Like in the bottom, you can detect the amount of substructure if you look at the flux fluctuations or time delays. And people is looking or starting projects to look into that. A second project that is also part of the in-kind contribution is software development to the dark energy science collaboration. In this case, this is being led by José de Santiago at Universidad. And the thing that they did as an in-kind was to optimize and parallelize some photometric redshift estimation code that already existed within the collaboration, but it was not efficient and quick enough for the LSST volume that they expect. So what José did, and actually he did it directly, was to optimize and parallelize this code. And here are some details of the work that he did. There is a team, there is always a team. It's not a single person effort, it's a team effort. There is another contribution, and in this case, it's a non-directable software development. This means that in this case, the dark energy science collaboration didn't say they wanted explicitly this as a priority, but this team proposed to create infrastructure to measure the 3-point correlation function in weak lensing measurements with a novel technique. And the collaboration was interested. They said, okay, this is good and will be useful for the full collaboration. So they accepted it and they are working on it. And well, basically they have developed a theory in which they can compute the 3-point correlation function in a harmonic basis. And with this, they can estimate it, they can compute covariances, and they have also the theory to do a good modeling of it. This is just some examples of the details of how they are doing it. And one important thing is that they are comparing simulations to theory right now because there is no data, so they are testing against simulations.
So LSST simulations?
Yes, I think so. And they are actually about to report that in an article, Arbizu et al. 2024, that is in preparation. It already passed the Dark Energy Science Collaboration internal review, so it's almost there. The fourth contribution is, again, a non-directable software. So this was a proposal from the team, but in this case, for the Galaxy Science Collaboration. What they are proposing and are delivering is a classification tool, an automatic morphological classification of galaxies tool, based, again, on in machine learning or convolutional neural networks in this case. And they are also interested in working at the low surface brightness structures. So again, as I said, this was not a specific need from the collaboration, but was something that the team proposed, and the collaboration said, okay, yes, this is useful for everybody, so let's bring it in. And the final in-kind contribution that is closely related to the science that our researchers are doing is to the Milky Way and local volume survey. So in this case, this is led by Ángeles Martínez at the Institute of Astronomy of UNAM in Ensenada. And they are looking at studies of star clusters. But in this case, well, right now they are working with synthetic star clusters, simulated data, to understand how well they can detect these kind of clusters in Rubin data. And they are still in the process to define exactly the details of the contribution, what is the in-kind contribution, but it seems they will also will do something with the how do you say, with the brokers. So they will also work with some alerts to provide to the brokers. And as before, there is some non-in-kind project that is going on in this collaboration that is regarding hydro simulations from the illustrious TNG to study the intracluster light as a tracer of dark matter halos. So these 5 in-kind contributions, as you saw, are closely related to the scientific interests of the researchers that are delivering it. And for us, that was very important because in Mexico, we knew we will not have the power to hire people to deliver something else that is not useful for us. So it has to be ourselves who are paying for our participation in Rubin. So what we do better be closely related to our interests. And finally, there is this contribution of the IDAC. You might know better what IDAC means. Is
Independent Data Access Center.
Yes, thank you. Independent Data Access Center. And in this case, it's Octavio Valenzuela from UNAM, who is making all the effort to get 2 petabytes of storage, 264 cores for processing, and 2 million CPU hours, GPUs were not actually in the original plan, but they have been approved and they are already in place. And right now they are on defining what will be the use of this IDAC for LSST. And as with DESI, outreach is an important part of our activities. So we have the Mexican Astrocosmos Statistics Schools that started actually in 2016, if I'm not wrong. And since the beginning, it was a school designed to start preparing people for surveys like Rubin. We do a lot of outreach events dedicated to Rubin. We actually designed this handcraft to construct the Rubin building for kids. And we try to have extensive presence in national conferences and web presence. Actually, this year in the National Physics Conference, there will be a Rubin talk, not given by Mexico, but by Melissa Graham from the Rubin team. But it's going to be present in this big national conference. And as I mentioned in the DESI presentation, we want to exploit the DESI LSST synergies because we have researchers involved collaboration. So it's a really good opportunity for us to look at it. And well, we want to make use of the education and public outreach efforts from Rubin. So I am actually very interested in taking this program of the Rubin investigations. Currently, there are 6 different Rubin investigations that cover different topics of what Rubin objectives are. And the idea is that you can train teachers to take these materials to their own classrooms. So we started, as Rogerio mentioned, with with Fernanda this year with this workshop for teachers, but I want to, at least in Mexico, I want to do it more frequently. And I have partnered with the local library to run these workshops with them in the local communities. And okay, funding situation is very similar to DESI. We have CONACYT and our own institutions with individual grants, and we have some non-financial support from now from two agencies. There is the Instituto Avanzado of Cosmología and the División de Gravitación y Física Matemáticas from the Physics Mexican Society. And well, they help us a lot with the dissemination of all the activities that we do. I think I'm going to move here. Yes. These points are a little bit different to what I wrote in DESI because the situation is kind of different. In this case, it will be very important for us to have access to be able to hire more postdocs or more staff that can focus on research to support the in-kind program. Right? It's kind of difficult that we as a researcher, teacher, and everything, we do our own science and pay the in-kind all at the same time. So it will be very useful to get more focused research staff to help out. Papers will take time to start flowing, even though we already have 2 papers on the can. It will take time because Rubin has not started taking data. So papers can be technical, and yes, of course, we can produce some, but it will take time to start seeing the paper production with Rubin. So we need some mindful evaluations about this for our researchers. And the mobility funds in this case is not because we want to show our work now in the like in DESI. It's because we really need to get expertise from the people that have been longer time in Rubin. So we are not just as a strong group in Rubin topics as we are, for example, in DESI. So mobility is different for DESI and for Rubin. It's necessary in both cases, but for different reasons, I think. And one important thing is that we would like to have a common fund for the LSST-MX common activities. Otherwise, we will advance at different paces of the project. And it will be nice to have an even support to all the projects. Transfer of knowledge is very important. As I said, there is going to be a wealth of data publicly available. So it will be nice to start preparing the community for the use of it. And of course, foster collaborations. What you said, like we should organize ourselves in the Latin American communities to look at key topics where we can collaborate together. Thank you.
Thank you. Okay, we're running a bit over time. Is there any quick question for Alma? If not, thank you, Alma, again. And now we have Marcelo Anda from EPN in Ecuador. He's going to tell us about the theory group. And I guess we might need some help too.
Thank you, Edgar. Nice to see you again. Could you make me a co-host or give me the permissions to share my screen?
I think you are co-host.
You are co-host? Is co-
Yes, you are co-host.
Okay, thank you.
Yep.
Okay, thank you to the organizers. It is a pleasure for me to give this talk here at the South American Institute for Fundamental Research. My name is Marcelo Anda, with the Professor Nicolás Vázquez. We are on behalf of the GIFT, the Group of Theoretical Physics of the EPN, Escuela Politécnica Nacional of Ecuador. So the structure of this talk is as follows. First, we are going to start with a brief history of the Ecuadorian University. Then I'm going to present the GIFT members and or collaborators. And then I will focus on our research interest, and finally with the conclusions. So let's start with a brief history of the Ecuadorian University. So in August 1586, the Catholic religious congregations of the Augustinians established the University of San Fulgencio, making it the first center of higher education in Quito. This first university responded to a need to influence the indigenous population in favor of the conquest and colonization of South America. The religious origins of higher education strongly influenced the development of university until the 19th century. Institutions such as the Escuela Politécnica Nacional, Universidad de Cuenca, and Universidad de Guayaquil were established, though education was not yet publicly accessible. In 1946, the first private university, the Pontificia Universidad Católica del Ecuador, was founded in Quito. Since 1992, the implementation of a neoliberal model in the higher education system led to extremely significant change. Higher education was largely left to the market, resulting in a proliferation of private universities, many of which were known as garage university due to their low cost and corresponding low quality and relevance. From 1993 to 2007, 45 new universities were officially recognized in the country, 35 of which were private and 2 were co-financed. Only 8 of these new universities were public, and they were established in the poorest provinces where market conditions did not encourage the creation of private universities. The following table shows the relationship between education investment in Ecuador and the gross domestic product. The left column shows the year, and the right column shows the percentage of the GDP invested. As we can see from this table, investment in education fluctuates year by year, in addition to being minimal compared to other state expenditures. It is worth noting that from 2023 to 2024, investment in education has decreased by 2.9%, which is more than half of the resources allocated in previous years. Let's continue with the GIFT. Currently, the GIFT involves 7 professors from the physics department. Here we can see them in this table. Lotfi Bobeker, his research area is cosmology, Álvaro Dueñas, high energy theory, Ollanes Fernandez in general relativity, Nicolás Vázquez in astrophysics, Cristian Vascones astrophysics, Ramon Chulbi complex system, and me in high energy theory. And also, these are our collaborators: Oscar Lazo from Universidad de las Américas, high energy theory, Clara Rojas of Yachay Tech University, her research area is cosmology, David Andrade from Yachay Tech, he do research in high energy theory, Andrés Vaquero, Universidad de la SUAY, astrophysics, Oscar Bustos of ESPE, his research area is high energy theory, and Julio Andrade from SPOCH also in high energy theory. The productivity of the GIFT group is the second largest within the university. The group has overseen around 40 undergraduate and graduation projects. Our research interest includes theoretical high energy physics, high energy astrophysics, and also we are focused on developmental projects. In the field of high energy theory, me in collaboration with other colleagues from national and international institutions conduct research in the relation of knot theory with physics. Some results of this paper are derived from my master thesis at Universidad San Francisco de Quito. In this work, we derived the equations of motion of the Chern-Simons-Wong theory. Subsequently, we stated that the fields A mu are functionals of the already given closed trajectories of the Wong particles in space-time. By substituting these solutions of the equation of motion into the action, we obtain the on-shell action, which depends solely on closed curves. All dependence on the A mu fields disappear. Due to the topological nature of the action, which means that the action does not depend on the metric tensor, the only topological invariant that can be described by an object dependent on closed curve is the way in which these curves are linked together. Therefore, the on-shell action must be a link invariant. As analyzing the complete on-shell action proves to be a non-trivial task, a perturbative analysis was developed, like in perturbation theory in quantum mechanics, in which we obtain links invariant at different orders. As this procedure is somewhat tedious, the idea that might exist some intermediate abelian theories, cousins of the abelian and the non-abelian Chern-Simons theory, which could describe higher order link invariant, arises naturally. This idea was previously explored by the Professor Lorenzo Leal of the Universidad Central de Venezuela, who developed an intermediate action for the third Milnor linking coefficient. Later in my master thesis, under the supervision of my advisor Ernesto Contreras, I developed an intermediate action for a 4 components Brownian link. In this paper, we also develop a new method to analyze the geometrical meaning of these link invariant integrals. So here in the following pictures, we can see some of the perturbative analysis of the Chern-Simons 1 theory. At 0th order, we have the Gauss linking number, as we can see in this picture. These are a pair of curves with a Gauss linking number equal to 2. The first order, we have the third Milnor's linking coefficient that describe the linking of Borromean rings. These are the two contributions at first order. And for the second order, we have some expressions for a 4 components Brownian link. We have 4 contributions to this order in these pictures. So we are currently continuing our collaboration in this exciting field. And another question that in this previous work left open is the following. Since the perturbative process is very similar to the one used in quantum field theory for the S-matrix when we studied scattering theory, it is interesting to ask whether it is possible to construct a Feynman-like diagrammatic approach to obtain higher order link invariance, that is for a Brownian links with n components. So if there exists some pattern that I can draw these funny pictures with components that all the components that I want. So the answer seems to be affirmative, and we are currently working on it. In the field of astrophysics, the professor Nicolás Vázquez, with the students Esteban Cárdenas and Nicolás Noriega of the Escuela Politécnica Nacional, and their colleagues Jennifer Chacón of the Pontificia Universidad Católica de Chile and Jonathan Quirola of the Radboud University, Netherlands, present this poster of their research titled Unveiling the Enigmatic Nature of Peculiar Long GRVs in Swift Earth Catalog, in the 32nd General Assembly of the International Astronomical Union, which was held in South Africa. Traditionally, long GRVs have been associated with the collapse of massive stars. However, their systematic search using recalibrated EPIC E-ISO plane has revealed that 7 LGRVs that defy the canonical classification. Recent reports of apparent long GRVs are actually associated with mergers and exhibit extended emission, leading to classification confusion. So, through meticulous temporal and spectral analysis, they provide insights into the elusive progenitors of these long GRVs. Their investigation includes examining temporal estimator from Swift GRV's observations. Future research will explore the properties of the host galaxies and surrounding media. By challenging established paradigms, they contributes to the evolving GRV classification and improves our understanding of these powerful explosions. Also, each year, the Gruber Foundation, in collaboration with the International Astronomical Union, funds fellowship programs for promising young astronomers. As in recent years, the selection committee decided to award this year's fellowship jointly to 3 outstanding candidates. One of them, Jonathan Alexandre Quirola Vázquez, we can see him in the middle of this picture, is an astronomer from Ecuador who graduated from the physics department at Escuela Politécnica Nacional and received his PhD in 2023 from the Universidad, Pontificia Universidad Católica de Chile, where he is now a postdoctoral fellow. He also holds a research position at the Escuela Politécnica Nacional Astronomical Observatory of Quito in Ecuador. In 2024, he will start a 3-year postdoctoral position at the Department of Astrophysics at Radboud University in Netherlands. His research is focused on unraveling new type of transient population, the fast S-ray transients detected by Chandra X-MM Newton and the Swift XRT, to determine the nature of the progenitors of the FXTs and their cosmic rates. He will identify the host galaxies and follow the contemporaneous counterparts using multi-wavelength facilities. In the part of developmental projects, the Meeting of Ecuadorian Physicists is an event organized since 1989, which is held every 2 years by the Department of Physics at the Escuela Politécnica Nacional. The event is aimed at researchers, educators, students, and professionals working in various branches of physics. The topics addressed at the last event were fundamental physics, condensed matter physics, astrophysics, applied physics, particle physics, geophysics, biophysics, optics, physics education, outreach, and engagement. The professor Nicolás Vázquez, in collaboration with the Office of Astronomy for Development and the International Astronomical Union, was working on the 4th Astronomy Workshop in Los Andes. This event aims to engage developing communities through astrotourism. The topics covered at the latest event were astrotourism, project for the integration of astronomical knowledge in touristical centers, cultural astronomy, and intercultural dialogue projects with indigenous communities. So finally, the conclusions, the GIFT are working with other Ecuadorian universities in the field of high energy astrophysics and high energy theory. We want to increase the collaboration with the ICTP South American Institute for Fundamental Research in the topics that we are currently working on. We also want to define the clear path for the Ecuador in the construction of a strategic plan based on the real needs of researchers and students, and hence the collaborations with the EAU offices. And as upcoming events, we have the 46th International School for Young Astronomers in Yachaytec, Utuquí, Ecuador, on July of the year 2025. So thank you.
Thanks, Marcelo. Are there any questions for Marcelo?
I just want to suggest to Marcelo, we have several workshops and events happening ICTP-SAIFR in São Paulo. They're more than welcome to apply to workshops, etc. We have funds, at least for local expenses. For you and for students from Ecuador. I think Edgar has sent
Yeah, we have sent a few.
students.
Marcelo, were you here?
Yeah.
Yes.
Yeah, I was at the holography at 25, where Maldacena give the close lecture. Yeah.
Okay.
It was a great event. Yeah.
Yeah, you have to keep it up at EPN. All right, any other questions? Otherwise, we'll move to the talk by José Ocariz, who stopped by. Thanks so much for stopping by, José. And he will give a talk about the topic with the best names, LA-CoNGA and EL-BONGÓ. So my first question is, who comes up with these names? Probably Luis, no?
No, in fact, it was LA-CoNGA was suggested by a colleague from Peru,
Okay.
who unfortunately then left the field. But this is a great contribution. Then EL-BONGÓ, I should say that I say we need to stick to tropical percussion. So. Of course, you have to force a bit the acronyms, huh? Audio. Okay. So it's a pleasure for me to have the opportunity of being here. It's not really, it was not really planned until a few days ago, but I'm very happy, and also the interactions I've had these 2 days. So it's a very, very nice opportunity. And of course, I've been a long-time supporter of the initiative, and we contributed both with LA-CoNGA and with my home country, so white papers in the previous edition and in this one. So today I would like to talk about LA-CoNGA physics, which was presented 4 years ago, but at that moment it was a project approved, so we had ideas of what we wanted to do, which did not include the pandemics. That was not the plan, but to some extent what we were conceiving allowed us to further, to nevertheless manage to work during those terrible times. Okay, so this is a talk that summarizes the activities of a large bunch of colleagues from the various institutes committing to the LA-CoNGA, but also a lot of individual help. So I will not name the lot because it would take too long. Quickly, a word on what is the idea. The idea is to inherit from our way of working in international collaborations and see in which way this could bring an interesting support to institutions that probably do not have locally the minimal resources in person power in order, for example, to have a full master's program with all the courses, etc. And this requires tools that are not only local, but also remote. So we have to look for a mixture of local and remote. And so that was the idea of LA-CoNGA physics, which we submitted to the European Union, and EU kindly approved our project and offered us with a budget close to 1 million euros. And the main objective in our proposal was to contribute to the modernization of higher education in the Andean region. I will talk a little bit more about that by building a network of common capacities in 8 universities. So to gather together people from various institutes. And in a more general way, it's a contribution to strengthening the collaborations between Europe and Latin America in higher education, also in science. And for this, we were very happy to rely on support and enthusiastic support of universities and research centers in Europe and in Latin America. And the proof of concept, what we actually wanted to build, because we have to build capacity. So what we wanted to build was a master level complete year in advanced physics. So advanced was very important because it's the A of CoNGA. And I should say that the European referees were very impressed by the fact that it was advanced physics. So think about this kind of things when you write proposals. Okay, so the idea is to have a unique cross-institutional program. So it's the same courses for all students in all universities. Technically, it requires that these courses have to be inserted into the existing master programs of each institute. So we're not building that from scratch. They have those masters, we add additional courses. What we build locally are interconnected instrumentation laboratories. I will give you more details on that. And the tool to share all of these concepts and contents is an e-learning platform that we develop ourselves. And I will show you more about that. It's, as traditional in high energy physics, is fully based on open access contents and tools. And the European funding allows us to fund internships for our students in research labs or industrial partners. And the idea is that they do the internship in another country. So they change that country. And the content of the courses has been calibrated from what we do in Europe. So we have this European credit transfer system that has been extremely successful in allowing students around Europe to study in several different universities, and the recognition of previously acquired courses is very, very trivial. And we calibrated our proposal on that. What is our consortium? So we have 3 universities in Europe, and Paris Cité is the coordinating institute. And as I said, we have 4 countries in the Andean region that contributed to the program, and in each of them, following the rules of the EU, we had 2 universities. And if you look at the consortium composition, it's typically universities that are either relatively new or that have relatively new master programs, that they are in an emerging situation. Most of them are public universities, with the unique exception of San Francisco and Quito. And in the case of Venezuela, UCV is the oldest and the largest one, and USB is, so to say, the elite university, but they are not in an emerging situation. It's rather the opposite, that they needed help. Among the list of partners, these were the ones that were included in the initial program, but this list has expanded. We have had the support, and very effective support, of CERN, ICTP, DESI in Germany, and in France, CNRS and CEA. There are other partners that have helped, and the coordinating was shared between me and Luis Nunez, that we heard from which we heard this morning. While in practice, we also worked differently. This is the official thing, but in practice, we have an organization that is very similar to what we do in high energy physics. So at least one person per institute is fully participating in the consortium meetings, in the decisions. And then we have a closer group of persons that include Reina Camacho that do the steering. And so the methodology for our purpose was to build this platform that we call MILAB. And MILAB is a unique connection point that provides access to a bunch of systems. So it's centralized approach allows us to very quickly, for the students, to be able to learn to use GitLab, Mattermost, Indico, Jupyter, and so they have resources to run codes, to have their data sets, etc. And this is still ongoing, but this also allows, up to some extent, to operate some of the interconnected labs. This is still ongoing, but we have some good points of that. We decided to do everything in Spanish. It was some decision among the consortium, but in the end, we thought that doing that in Spanish could potentially allow some students to better benefit from the program, while in practice, most of them are at least minimally fluent in English in order to follow courses, etc. We did not see any issue with that. And all our material is open source, so it can be accessed online.
Who writes this material?
Ourselves. So yeah, I could have invited you to either one or two talk. Watch this, and yeah, but your point is fine, so that's why I should have thought about it. Okay. This slide here summarizes the structure of the syllabus in a slightly complicated way, but I think it makes sense to show it like that. So this is time. So this is the beginning of the year, end of the year. In Latin America, it goes from January to December, in contrast to Europe. And we have a sort of first semester with what we call the introductory courses. And they are split in 3 branches: theory, scientific instrumentation, and data science. And the 3 branches have the exact same weight. So in total, at the end, the number of ECTS for each branch is the same. So we are not advantaging any of this. This is something that was not really present in the institutes participating in the project. This was really an innovation for them. Then we have a second semester with advanced topics and options, which is shorter in time because we wanted a long, at least 3-month internship. And the internship, as I said, is in international mobility once the virus allowed our students to travel. There seems to be a question by Mauro.
Yes, thank you very much. Short question. In your first column, what does the depth, the dimension mean? I don't understand that.
Yes, the reason why it's like that is, for example, because in data science, we have several courses. There is a introductory course so that they get a hands-on training on Python, etc., so that they know how to do things. Then we have a course, a formal course on statistics, probability and statistics, and then we have a data science project. And
I see.
instrumentation, there is first a course on instrumentation, there's a series of courses on detectors, and then there is a instrumentation project. And so I didn't want to give all the details because 20 minutes is short,
Sure.
but yeah, the structure is also three-dimensional.
Okay, thank you very much.
Okay, in our web page, you can have more details on that. And the link there should work. One interesting and I think original thing that we did is the theory course. The first theory course, which we call generically field theory, starts with a common block of 8 weeks. And after those weeks, the students decide whether they are more interested in high energy physics or in complex systems. So they are all given the same training at the beginning. Those who choose complex systems will nevertheless have a lecture on the Higgs mechanism, and those who choose high energy physics will nevertheless have a lecture on superconductivity. And after that, the thing is split, yes. For data science, you already, in answering Mauro, gave some of these details, so I can go quickly on that. But a strong emphasis here is scientific reproducibility. So we want our students to do their coding properly in a way that resembles a professional approach. And the statistic course is aiming at scientific inference. So we don't want them to use some tools as black boxes. We want them to really understand what they are doing. And then in the second semester, there's a course on machine learning, which is more advanced. On the scientific instrumentation, we bought with our budget a series of equipment. So nuclear physics kit from CAE. So each of our institutes have received this. Okay, so this allows them to have to do practical projects with scintillators, with silicon PMs, with spectrometers. We also about generic toolkits, protoboards, oscilloscopes, function generators, which are integrated. So there is one very nice from National Instruments because you can access it via Wi-Fi. So it was among the first things that we managed to have working during the pandemics, when there was no access to the campus. And a Colombian startup has built air quality monitoring stations. And we have installed them, and this allowed them to read various quantities, temperature, pressure, but also particle content, etc. Interesting for pollution. We have a startup from Spain interested in educational projects that has built remote controlled experiments on cows, like Chua, circuit, double pendule, etc. And these are quite well advanced for being managed remotely because they were conceived for that. So it was something that was not initially foreseen, but when we discussed with these people, they were very interested in what we're doing. And the material belongs to the university. So EU provides us the funding, but the property is to the universities. Special case for Ecuador because they didn't allow us to buy the one with Wi-Fi. Don't ask me why, Edgar, but so we had to buy an alternative, but that works very well anyway. Then for the internships, as I say, the idea is that the students have some mobility. We strongly favored mobilities within Latin America to move to another country. Students from Venezuela went to Ecuador or to Colombia. Students from Peru went to Colombia. Students from Ecuador, one student from Ecuador went to Peru, etc. So this kind of rulings. For some specific cases, when the student results were excellent and when they had a very, very well defined project, they came to Europe. But this was more the exception than the rule. And then at the end of each year, we all gather together and the students present the result of their internships. So we have had already 3 complete cohorts, and the courses continue this year. On top of that, the idea is that in LA-CoNGA, we have a living experience of creating a community. So we have a number of additional activities. So we have bi-weekly seminars. I'm giving here two examples of guests for the seminar. So Leticia Cubiandolo from complex systems and Fernando Quevedo from high energy physics. Each student is assigned a mentor from another country, which with the idea of developing among them a close-by interaction, individual interaction to follow up the students. There are additional activities, for example, for the 10th birthday of the Higgs boson, we did a special workshop, workshops on gender in science. Since 2022, we have these hackathons in which people who are not necessarily LA-CoNGA students join for one weekend and solve problems and get some of them become winners at the end. And with high schools, these air quality monitoring sensors have been installed so that the kids in high school have some first initiation to that data analysis, etc., and play with those numbers, try to correlate their results with results from other high schools. So here are some summaries of things. So the proportion of students from each of the countries, this has been a bit time evolving. Unfortunately, the representation of female students remain relatively low. This is bad in physics everywhere, but we didn't manage to be better than the other ones. And this is interesting because these are the current students. As you can see, if you read, there's a bunch of students from universities that are not part of the consortium following the courses. We had already some examples in the past. As you can see, there are some small numbers there, but this is a good success of what we're doing. Concerning the courses, so that's only for the students who validate the courses, so who succeed. The attendance was typically larger. And as you can see, data science was the favorite course for reasons that we can understand, because these are skills that are considered good for various projects. Here I enumerate some points on what we consider our own evaluation of failures and successes. We think that our syllabus sharing data science, scientific instrumentation, and theory is well balanced and well suitable. We think that what we have done can be done by other communities and by other institutions. And the scientific diasporas from our countries are these concerned colleagues that live in other countries, myself, who lives in France. We have gathered many of them. They are enthusiastically volunteers to help on this thing, so just for the pleasure of doing it. So this has worked fine. One thing that was difficult, and I did not foresee that initially, is that typically master students work to study. They pay their studies by their own work, and therefore commit to a full-time program is really a challenge for them. Okay, so the numbers I show are just for those who succeeded, and we have no obvious possibility of solving that, and that's really a burden for us. This means that we have to be more flexible. We cannot expect them to be 100% dedicated to the courses. We must allow them to do that in 2 years, or just to choose a subset of courses. So we have to increase the modularity.
So a quick question.
Yes.
With this money that you have, can you offer fellowships?
We did not initially foresee that, and I do not think that the Erasmus rules would allow us for that. Mobilities are funded, but not subsistence.
Okay.
Okay, and the other thing is that even if it was interesting to buy equipment with a Euro funding, we noticed earlier and discussing with colleagues, especially from Peru, would be better that we have fab labs and that we build at least what can be built locally. And technical issues on the fact that since the students are receiving a certificate that they validated the courses, the universities in the consortium recognizes that, but for other students on other universities, it's not so obvious. So each time we have to try to negotiate this thing so that this can be validated. In 1 minute and a half is going to be tough, but we decided under strong pressure from colleagues who told us that it would be a mistake to have a gap between the two European programs to submit a proposal in February. I was not very optimistic, but we were approved. EL-BONGÓ physics was born. The European constraints are different in the new Erasmus Strand 2, but this is the distribution between the payment of the colleagues working or the staff that has to be hired, the equipment, the travel, and the subcontracting. So it's not so different from what we had in LA-CoNGA, but we increased the size of the consortium.
It's 4 years also.
It's 3. So one excellent thing is that now the coordinator is in Colombia. So Gabriela Navarro is the PI. Okay, so I'm very happy to be now just co-PI. Okay, so on top of the institutes that we already had, we included one additional university in Colombia, but we included 3 countries from Central America. Okay, and we have other contributors from Europe. So in a nutshell, the idea, since we had to propose something different, the idea is to inspire ourselves as much as possible on the successes of LA-CoNGA, but to open the scopes. So discussing with the people in Central America, etc., we decided that seismology was a very important topic to be included. Space weather astronomy would benefit from activities done by several colleagues in the consortium. Artificial intelligence is, of course, mandatory because otherwise people don't believe in you. And it makes sense. It's completely sensible to do that. And so we are at the stage of building things. So we just approved in July. We aim at first courses in 2026, so we have to prepare the thing. But you more or less understood that the idea would be that we keep the one-third distributions, but the theory courses have to be adapted to the various different topics. Okay, and so it has to be more modular so that students can choose small chunks of training depending on what are the individual training projects. And so with the European funding, we will build fab labs in each of the institutions. That's what we wrote in the project. We want to make MILAB more professional because written by particle physicists and a couple of engineers who would like to have really professional people rewriting the thing, etc. And the new partners will need to have or create a master's program. We will very strongly insist on having the activities of our colleagues recognized within their institutions. It was not always a success in LA-CoNGA, unfortunately. They have to provide physical space for the fab labs, and the idea is to get students, of course. So 2023
wasn't really recognized.
Sorry?
What do you mean it wasn't really recognized?
It depends a lot on the university. It's very university dependent. But for example, you have a colleague that makes 60 hours of lectures. Yeah, Chinese. And the university took the money from this activity and did not inject it in the project. For example, in other universities, they could use this support because it became money from the institute and they could pay some students. So if I work 1 day for LA-CoNGA, the European Union has a barème, how to say that in English, a valence, they say. A work of a guy from France costs that many euros.
Yeah.
This money belongs to the university, but we manage with most of our institutes to have them committing that this money should be at least partly inverted in the project, in enhancing things. But we did not anticipate that this required a negotiation. Now that we know, we are starting from the beginning saying that to our new partners. We need you to commit to that. And final words. Obrigado. Gracias. Thanks a lot.
Thank you, Jose. We have time for a very quick question. If there is any from outside or,
Yeah, I do have one. So exactly how our institutions can be involved in the process? What is the process?
The European Union has some rules which are quite strict. So you have a number of institutes per country that can participate, countries that are eligible or not. And in our proposal, we define what are the activities of each institute. And so, for example, San Francisco, one of our colleagues is an expert on instrumentation, so he was the leader of the working package on developing the platforms. Bogota was very strong in theory, so they are the leader of those packages, etc.
So if more institutes want to join, you need to make a new project.
Yes, but I should have written it. Institutions that were not in the initial project had colleagues interested, either in teaching or in providing us with students. In Colombia, it was very easy because Colombia has a national program to recognize credits among institutes. So we had students from several universities in Colombia. In Ecuador also, we had students from SPOC, which is not part of the consortium, so we not send money to SPOC, but students from SPOC had a specific agreement with San Francisco, and for two of them, we wanted to send them in mobility to Peru. One of them had issues with a visa or whatever, but the other one did a complete internship in Peru.
So you could have participation that is not officially part of the grant.
In our open logic, if we have a student interested in what we do, and a colleague in his or her institute that takes the burden of making sure that her credits or his credits will be recognized, this person is welcome.
Or I guess teacher.
Yeah, so teachers from the institutes, the university receives money. Teachers from other institutes, they do it because they are good friends of us, or they like the idea. And it's a large number of persons. Luis showed this morning that there is a workshop on astrophysics and cosmology, and if you see the list of speakers, it's flagship. And something that I forgot to write, and this is a mistake from my side, we have 3 LA-CoNGA physics alumni that have done the CERN summer school last year and this year.
I was wondering if the 3 months internship could be a CERN semester.
Unfortunately, we tried to do that, but there were many constraints. So the people interested in doing LHC went to Paris. And once they're in Paris, all of them went to CERN at least once.
I have a question about this. These Erasmus, do they have the same problems with for an example, the Horizon 2020? I'm a member, for an example, of the vector scattering project, and from what I understand, this is very different from what we had. For example, when we had Ellen, we were able to have mobility program and bring students to CERN, bring students to European institutions, and with this current, I don't know about the Erasmus, but the current Horizon 2020. We can do anything in terms of funding, mobility. I basically can watch people work. It's very tied up, and it's good just for Europeans. It's not very good for the foreign.
Yeah, Erasmus Plus is for non-European regions. So they have geographical priorities. In the case of Latin America, some countries are not eligible. Is not eligible. And they are more interested in things that they call capacity building, transforming something within the institutes. So it's there are other programs like Erasmus Mundus, which are classical training, so it's just mobility. But a large fraction of the budget has to be devoted to instrumentation and the transformation of things.
All right, thanks so much. Let's thank Jose. And we need to move on to Arturo Sanchez, He's gonna talk again about, this time, about transversal computer strategies and services for last free.
Hi
So,
guys, can you hear me?
yes, we can hear you, Arturo, and you may share your slides.
One participant at a time can share. Okay. Sorry. So let me know when you can see my browser, please.
We can see it.
Thank you so much again. And this time I promise to be on time. Thanks again for the opportunity on talking on this project, this proposal, essentially to keep bringing the subject of this kind of transfer infrastructure, this kind of resources that can and are already helping many of the projects you already saw, for example, for the presentation by Jose and before that. So obviously, I just wanted to say that what I'm saying obviously is on my own ideas and proposal, and obviously right now I am still a physicist at my heart, but I work in a private company, so that also brings this clarification super important. So putting that out of the way, one of the reasons why I keep coming and bothering you guys on these events and others is on the matter of bringing the subject of how to continue building infrastructure that can be used for many people, and more recently in how to not start because we already do it very well, but how to continue doing it and professionalize the usage of infrastructure, the cloud infrastructure, the computing infrastructure, the software infrastructure that is already, the last time that we met again 4 years ago was halfway between be something exotic and a utility. Right now is entirely a utility, the same way that we use electricity, in the same way we use Google to search or other browsers or other searches. We can do the same things with this kind of infrastructure. So I am bringing to you this series of ideas and more or less teaching you, let's say, coming from a background in terms of how to do this in higher energy physics, but also for the open access atlas where we continue working on this. So these are some of the reference, not so much about the white paper or the background or where this is coming from. As a person who was working for many years at CERN, managing basically all the data taking of Atlas experiment, and right now doing the entire infrastructure, the computational infrastructure in an AI company, I can tell you that we really share many of the two things, and we can really put it together in even better. So again, all this come back to connect people, data, software, and resources. And this is something that we heard already several times in the multiple presentation before me. But one of the things that I would like to emphasize is in the avoiding to trying to replicate infra that already other have when it's not really necessary. And focusing more on the strengths in the region and that is essentially our human capital, the people that can learn to level up these kind of technologies that more and more are very in standard of the industry. So things that we do they now do at CERN every day I can compare it one-to-one with things that we do in the industry every single day. So the exchange between the tools back and forth between the academy and the industry is something that, especially in very large collaborations, is done very well. But the idea here in this white paper is to bring it to the point that we essentially take advantage of this and integrate it already in our way of collaborating with others instead of try to follow them in one-to-one what the people is doing. So again, I have been speaking about this since a few years already, more and more since I started to collaborate with the different open data projects, and when we managed the Atlas open data project, and even right now when we still collaborated on that, because it's even when I am not an Atlas member since a few years, it's an open access open data project. So we can continue doing this thing. So this is something that we can also continue to be doing even if we are in different part of the world. So this is more of the content, the white paper, and I will at the end obviously send you the link. So if everybody wants to go more in depth on this. But essentially, at least in my mind, obviously the things depends on your expertise, but we have this kind of to work with different experiments, different laboratories, different experiences that are happening, have different way to go into the publication, into the access, into the, sorry, because I need to hide Zoom so I can see my own slide, into repository, software repository in this case, or other kind. And at the same time, how the computing storage, the software, I mean, the execution of the software and the monitoring of the infrastructure is done. So I focus it mainly to say, okay, and this is something that is very, very much known by everybody here, that we can take the first half and we are already standardized many of these things, because we realize that some of these things are at this point in now, at this point, let's say, they are utilities. Utility in the sense that we know where is the place to put publication, the ways to create a digital object identifier, a DOI for our data set, for our paper, for our master thesis, that maybe, you know, undergraduate thesis or laboratory report, things that still we wanted to be indexed, we still wanted to be accessible, we still wanted to try to keep the credit of the people who generate these things, because obviously, especially for the younger people, this is the way that little by little they are creating their own curriculum, and it's not always a thesis, sometimes are reports, etc. So we already are quite good on how to publish and how to organize the scientific production, and for our individuals, you and me, and even this the institutional level. So we have repositories here, and again, no need to go into the detail, but this is something that we understood, that there are common service, common infrastructure that is there, that because it's used by many of and other people around the world, multiple people keep funding this kind of infrastructure. So meaning there are some software repositories that are there. There are places like Zenodo that were all, by the way, all the 2019, and hopefully not, and the 2024 white paper will be also hosted. This kind of infrastructure is founded because people use it. So we understood that, and we are doing that since very well. So that means that publications go into platform as a services. Those in the same way. There are platforms, generic ones, but also by field. You can see very well how the people, especially using medicines, have their own repository. But essentially, there are places where people on the different fields know where to go first. And you heard during the last 2 days, people who essentially check Google Scholar to see their own country's production, scientific production. So this is an utility. This is what I wanted to insist. And sorry, I will be using the same word many times. So, but in the case of the infrastructure, is where the focus on the history of the two white paper and the professional experience I have here is to try to avoid to go into this race. And again, these are my words, maybe on the impossible to win race to try to match infrastructure that other economies, other established economies already have in their facilities, but instead to go for using those as a commodity. On top of that, build something new, collaborate in a faster way, because we are able to learn. And again, different experiences during this workshop show that we are being very good creating capacity building cross countries, cross borders. And the idea will be to use this infrastructure that is there to enhance already the production. So we can continue working in the experiment that we are doing. We can create new collaborations, and essentially the point here is to enhance the human capital, to improve learning all the state-of-the-art programming, computation, and infrastructure skill, design skill. And again, with the coming of the tools like artificial intelligence that have to be mentioned, but in a serious way, I have been seeing in firsthand how all this generative essentially allows you to be much more productive, allows you to have an agent, as they call it, that is able to interact with you and to bring a lot of knowledge right away. So if you essentially, in a similar way that the several economies just jump into on technologies and go forward in another established economies, we can do in a similar way, not simply, of course, there is a lot of work to put here and it's already ongoing, but essentially on bringing these kind of technologies that are already at the edge and using the infrastructure that is already there and not to try to create it again. So this means, in short, to use a lot of these substantial commercial services. And commercial doesn't mean pay. Commercial, because when was the last time that we had to pay to find something on internet? And we can come into the debate of how this infrastructure is paid. But what I mean to say is that we as a researchers, as students, as people who want to learn something new, use the internet to get this, and these are infrastructure put by somebody else, and we use it in the best way possible to get our objectives. In the same way, more and more, these kind of computing facilities, what it is cloud computing, what is storage, what is the storage of the software as well. I mean, especially very important to do continuous integration and continuous development. And people who have been working in computing zones knows that these two pairs of words are super important. That means the reproducibility of the infrastructure, the fact that we can, given a certain amount of computing power, reproduce experiment, reproduce the analysis of data. And this is, for example, super key, obviously, in large experiment, but even more important in small places where maybe the infrastructure that you need it quite specialized, but not for a very long time. And these kind of services can help on this kind of situation where you just need to sell infrastructure for some time. So again, if you have been seeing the evolution on the right, sorry, on the different draw, but essentially what I mean is that we can really create or have these common services and infrastructure. And this means use in a smart way all the different infrastructure that these different companies are giving to the people to be used in our scientific production. And this is something that is very well done in large experiments. I remember being at CERN and collaborating for private companies to enhance the software that we were using, to enhance the security of the computer that we were putting together in exactly the same way. Right now we do it in the private sector. And what I can say is, among many things, is that the skills are completely exchangeable. You can really work in both areas. So we have proved in several smaller scenarios that using this kind of infrastructure can really make a difference, for example, to teaching workshops, to teaching courses. I mentioned in the presentation about the Venezuela's collaborations and for example, with regards to the war in terms of the Physics Without Frontiers instead of outreach, etc. We use this kind of commercial infrastructure in a very successful way in places where it's very difficult to have it otherwise. So the idea at the end is to find common environments where we have computing that, again, not to say that the university doesn't need to have it. The university obviously will, the institution have these skills and the production of the engineers or the physicists that want to do this thing, or sometimes they just, part of the job is have to be the case. Many of these tools, again, are open source, even when I managed by different companies, in the same way that CERN managed Root and many other software. They put it together to the community, and the community together enhance this kind of thing. It's right now happening with multiple machine learning and artificial intelligence models that are open source, but managed for different companies that are put into the science right now without any issue and with minimal friction because of this exchange of skill and common services that they use. So so what is the idea? To keep bringing these kind of generic tools to be more looking forward how to use these kind of commercial services to do our science. That is something that will for sure enhance what we are doing right now in different institutions. I particularly keep going to these round trips even when I am outside the community right now. I just, for example, want to mention I was a few weeks ago, this is 10th of June of 2024, so I'm not telling you stuff that would happen 2-3 years ago, when we were, for example, in Venezuela, doing something very similar to what we were doing in previous year, and something that was super, I mean, one of the environments, for example, in this particular place, Even unfortunately, we suffered a couple of energy cuts during the 2 days conversation. We were also in another university in Caracas. But even though every single person that have a computer at that moment was able to run a large language model on the cloud. So this is what I mean to say is that at that point, we have something like 200 different computers, all of them for free, bring them to teach them how to interact with the open source large language model at the same time. And this is the kind of environment where I try to challenge myself with this idea before to come and bother you for 20 minutes. And in the sense that there are ways to use this in scenarios like challenging like this one, but not only. And so coming to my conclusion, the idea is to keep bringing this kind of technology because it also helps us to do this mix that we very much wanted and very much looking for, and still, and we try to build between the industry and the academy, where the industry brings ideas like in the something simple, but still quite cool to see in the hackathon, like Jose mentioned, and that we have done several times, where we have the excuse to invite institutions and also to invite companies that can found this little project, but also see possible talent on this. And that means also that we can have multiple opportunities for the people who have there. Maybe they do love science, but then maybe they can find also a job in another place, or knowing that what they are learning can be transferable in other areas, in other places. With this way, we also, for example, I talk in this case on the name of Creative Commons Venezuela chapter, also working with Creative Commons that found some of our projects. The company where I work also found part of the events that I do. They led me to do this. They even donated several hundreds of computers that I now need to transfer to some of these. I mean, this is something ongoing, but what I mean to say is like when you bring this kind of ideas outside and explain what they are important, and they are very glad to help, very glad to see how things that maybe for them are not so useful now, for us could be extremely valuable. This time I promised to be short, so I think this is all. Yes, the other I can jump it. Thank you very much, and I don't know if there is any question.
Thank you, Arturo. Are there any questions for Arturo? If not, maybe I may have a question, and not only for you, but maybe to the people doing large experiments here. So I guess we listened this morning about problems always with the storage, for instance. And so I was wondering if you have considered, or if collaborations in general consider, for instance, using commercial storage capabilities in the cloud. Is that taken into consideration at some point? It is not worth it. What is the approach? Do you know? Maybe I'm looking to you. This is because I know.
I mean, the data solutions are at early stages for SWQ, so we haven't really discussed that. For Cité, I haven't seen commercial solutions being discussed. I don't know if there is a study on cost effectiveness, or if people in academia and great large experiments prefer to have a full handle on the things they're doing. It could be that in part, so it could be a cultural thing in a sense. So I don't know. I wouldn't have the answer. But I'm sure the tools are becoming more and more cost effective. So at some point, they might be interesting.
This has been discussed in Atlas.
Oh, really?
If I can add,
Checking whether can use Google facilities for storage and computing.
I thought it was more about computing than storage.
Yeah. At some point, CMS also, let's say, use software.
The LSST is in partnership with storage. Well,
I can also mention that, in fact, for example, when I work also and see in the SCAPE project, also another European project, It's not so much to long-term storage, because again, if you have the opportunity to have your own disk, it's better, like people that CERN does do. But for this kind of production of data, so again, you have some kind of enhancement of the data, meaning analyzing, but not only. Sometimes you need to enhance it because you need to merge it, because you need to put it together, because they were from different periods, and you want to do a single batch, etc. That is, this kind of transcendent storage is very much done in cloud computing, commercial cloud computing, because it's this kind of peaks. No, you can imagine, not in terms of computing power, but in terms of, I will need 100 terabytes, but just for 2 weeks. And it's this kind of situation where it's very cost effective to simply, maybe not the right word, to put it on the cloud, commercial cloud, and do the job for this 100 terabyte that you will need to put the old data, the mer data, and the results, and get it away and get it out back to the disk inside your facilities. So in this case, it's something that is done since several years.
Okay, thanks.
Just a quick comment that for LSST is not only that the data will be in the cloud, but all the software is being built to bring the software to where the data is, so that you don't download it, because it's impossible. It would be impossible to compute all the data. No, you have to bring the code to the data.
That sounds smart.
You have the index.
Yeah, but the index will be mostly for some, how do they call it? Enhanced data products. So something that you already get from the large volumes of data that is smaller and that is more manageable to have hosted in the index. And that is of recurrent use for many scientists, for example.
Yeah.
But most of the things will be done, you taking your code to where the data is, not as we are used now that we bring the data to where the code is.
Yeah.
Okay. Yeah, let's thank
you, guys.
And we move to the final talk of the conference. Melissa Cruz is going to tell us about the Central American effort. Melissa?
Yes, hello, can you hear me well?
Then you can share.
I'm sharing. Just let me put it in full screen. And that's it. So thanks a lot for the opportunity. I'm going to present this on behalf of the Central America representative from Guatemala, Costa Rica, and of course, Honduras. And so we decided to submit one single white paper, and this is what I'm going to talk now. So the main authors of the white paper that we submitted are here is María Eugenia Cabrera and Juan Ponciano from the USAC, la Universidad de San Carlos de Guatemala, Sergio Arguedas Cuendis in representation of the Consejo Nacional de Rectores CONARE, and myself, Melissa Cruz, from the National Autonomous University of Honduras. So, and this is just to get to know the representative to the preparatory group, María Eugenia, and this is Federico Muñoz and myself. So I'm going to start by talking about Guatemala and the scientific context of Guatemala. So the high energy physics community emerged in Guatemala back in 2015, thanks to the birth of the physics research program at the USAC. So the effort from a small group of scientists from USAC are the ones leading the research activities that in theoretical and experimental high energy physics and astrophysics. So the group is actively working in, for example, in the establishment of local and regional high energy physics networks. One of these is successful, was created back in 2020 that is called CAHEP, and it was jointly with Honduras and Costa Rica. They are also looking for the establishment of sustainable and fully functional postgraduate local programs, and this is still an unachieved goal. But nevertheless, there are ongoing local master programs, and there is also an initiative to a joint a Central America PhD program. This is something that needs to concretize. There are several talks and so many, well, several years now, but still it's not a reality. Guatemala is also participating now in the side, from the experimental side, in the LAGO experiment. They joined the collaboration of LAGO in 2011, scientists and students from the USAC and Universidad del Valle in Guatemala. The projects include the construction of a low-cost water Cherenkov detectors. At the present, they are in close collaboration with the ICTP Multidisciplinary Laboratory, MLab, and they are focusing on the design, prototype, and test of the detector electronic readout and data acquisition system, spanning from kilo electron volt to giga electron volt energy range. They are also involved in works with the LAGO simulation teams. They are modeling GRBs, where they are the gamma ray bursts behave through their path in the atmosphere as air showers until events are triggered at the detector. So the high energy theory in Guatemala, I mean, they were able to start a small high energy physics community. They are mainly focused in phenomenology of dark matter and beyond the standard model of physics, but they still face some challenge. The main challenge is the capacity building. For example, the brain drain, the lack of scholarship for postgraduate students, and a small number of research positions. Actually, this challenge, I think, is something shared among all the Central American countries, and we'll talk more about it. So ongoing efforts are focused in the consolidation of Central American group to engage more students and researchers. As for from the side, I mean, also from the experimental side and high energy physics, there is an ongoing initiative and prospect for Guatemala to sign a scientific and technical cooperation agreement with CERN. This will represent the first step from Guatemala to establish in a CERN experiment. Guatemalan authorities are currently in discussion, and they aim to attract high qualified scientists in the area of data analysis. So this is something that is beginning. They are in this talk to make this macro cooperation agreement, and then they will have to go through the memorandum of understanding with one of the experiments at CERN. As now for Costa Rica in the scientific context in experimental high energy physics, well, Costa Rica in 2014 signed an international cooperation agreement that was ratified by law in 2017. In 2020, is born the initiative led by CONARE to make possible Costa Rica to join the LXV experiment. So in June of 2022, CONARE Group was accepted as a full member of LXV. This is very recently. And this one here is Sergio, that is based at CERN right now, but its affiliation is the Universidad Estatal a Distancia. So this marked the beginning of the experimental high energy physics group within Costa Rican University. In the past 2 years, they have gone to a training period and a search of area of knowledge where there is person power available. So the research activities have been concentrated, for example, in studies of very rare decays and dark photon through count decay into 2 or 4 leptons. Uncertainty estimation for machine learning models used for fast simulation and data analysis in HEP. They are also working in decoding and particle reconstruction using GPU algorithms, R&D in scintillating material for particle tracking detectors, and the design and development of access for readout systems. And also they ensure to send students to the summer program Observe, and which is very good. And this is one of the students, Matias Leandro, who actually was awarded with one recognition from LXCV for a very good work that he did during his summer stay. Also, Costa Rica is involved in several outreach activities in the sense to motivate a young high school student and then to pursue this path in physics. And they, for example, do this too for the LXCV masterclass using the open data for high school students and the what you call the UCC, Jornadas Costarricenses en Investigación and Computación. This is, so he's here too, again, and that's it. As for the future plans and challenge, the experimental health community in Costa Rica has just started and is still very small. In the near future, the goal is to consolidate this group by building the critical mass of researchers and students needed to get more involved in physics analysis. This will be done not just locally, but projected together, mainly with Honduras and Guatemala, but always trying to increase ties with other Latin American countries. Strengthens the connection of Costa Rica engineering community with the high energy physics, and also get more involved in the high performance computing facility for HEP data production. And next year, Costa Rica will be the place where the Latin American School in High Energy Physics will take place. You probably know that it's a very prestigious school and happen every 2 years or 1 year. I lost, but yeah, it will be in Costa Rica. And now from Honduras, well, the scientific context where research activities in high energy physics are mainly conducted by a small group of scientists of the UNA, or National Autonomous University of Honduras. It is the only university in the country that has a major in physics and has a master in physics too. So the theoretical efforts are concentrated in this topic, for example, the LSST methods in scattering amplitudes and quantum gravity for dark matter, quantum gravity and supergravity, relativistic kinetic theory of collision with gases, gas and curved space-time, and the study of cosmology, inflation, and cosmological perturbation. As for the experimental side, individuals from UNA take part of the LXCV experiment, but still there is no memorandum of understanding. So I will talk more about in the next slide, but thanks to the collaboration bonds with the LXCV Rio group, there is a participation from Honduras in the LXCV experiment now, and the efforts are alienated with the scientific program from the LXCV in the study of CP velation phenomena in sharpness decay, hadron spectroscopy study through amplitude analysis approaches, among others. So what are the challenges? From the theory, we can say that still are very few working in each research area, for not saying that they are very, most than a group working in each topic that I just talked, there are individuals working in these topics. And they are making their most with resources available and in attracting students, but still the theory community in physics in the country is very small. Individual connections and collaboration with research group of other countries, for example, Guatemala and Mexico, helps to reduce this academic isolation. So still, this is something that we need to grow. As other Central American countries, the key point is capacity building, same issues, brain drain, lack of scholarship for postgraduate students, a small number of research positions, because it's in Central at least in Honduras, a student, postgraduate student, master student, they need to pay their postgraduate. There is no scholarship. So in that sense, they need to work to pay the master program, and that makes an impact in, for example, all the time dedicated to do research. They usually want something or do project that can launch then to the industry and you know, make money faster. All that. As for the experimental high energy physics for Honduras, we still don't have a memorandum of understanding with LXCV, but the path to go there is in progress. Since the end of 2019, Honduras have been working in these efforts to join LXCV. The first step required was the Scientific and Technical Cooperation Agreement, Honduras-CERN. This was finally signed in 2021 by Honduras Institute of Science, Technology, and Innovation. Innovation is Cité, now called also CETACIT Cité. And the previous attempt to consolidate this agreement happened 40 years ago. So it was really a huge gap between the first attempt and now the following attempt that was in 2018, but it was possible. And now for the memorandum of understanding, the projection is that it will be institutional. I mean, it will be UNA LHCB as an associate member at first, and with the projection to grow as a full member in probably 5 years. So the UNA authorities are very interested and aware of the scientific benefits of this project for the university and education. We are in the process of our first draft of application with the LXCB membership committee. So we expect to, by the end of this year, to finally to enter to LXCB formally. So for Honduras, I can say for Honduras, most countries in Central America, the theory and experimental groups knowledge that to strengthen our community and grow in capacity building and academic research match, the association with other Central American countries for regional project is a key point. We also acknowledge that regional postgraduate programs are good and a strategic path to follow, but this has to go hand by hand with opportunities of research and academic positions available in the countries. Some initiative has started to make noise, like the creation of advanced studies institutes in order to ensure free and creative academic development, but still there are just ideas. Kid academy bonds with industry is something to be exploited. I mean, it's still not. Support from the government is needed in all the spheres. For example, I just mentioned scholarship from for students to pursue postgraduate programs in the country. So this concern, I can say, is shared among all Central American countries. As Central America joint efforts, we actively try to apply and to create projects that can strengthen our capacity. For example, I just mentioned that CAHEP network. We created the Central America in High Energy Physics and Scientific Computing Network back in 2020. And since then, we have a regular meeting, and we have trying to make projects that involve students and trying to share resources. And this is something very good. So this is one. The other one is AlphaCent. This is Astrofísica Centroamericana y del Caribe. And this is also initiative was from Paola Oliva, that she went to Australia to make her PhD, and then her and another colleague from Central America, Rodrigo, from also colleague from El Salvador, they created this initiative, AlphaCent, that they do the connection with researchers and students, so the student can make the research project with researchers and professors from all over the country, over the continent and Latin America.
Minutes, Melissa.
Yes?
2 minutes.
2 minutes. The Central America, also we did the CRISCA conference. It was from Guatemala, Honduras, and Salvador. This was recently, and now in July in Copan, here in Honduras, the Regional Integration in Science Conference on Physics, Astronomy, Climate Change, and Mathematics. We also have applied to SUCA's proposals, but we actually passed the first selection stage, but not the last one. And finally, we are now working with a project with Physical Without Frontiers. We are planning to do a hackathon with some open data by the end of this year. So we are in the preparation of this. So this is part of our challenge and our current projects. And I think that's it. Thanks a lot.
Melissa, other questions for Melissa?
I just want to tell Melissa that we got in touch with the AlphaCent in order to implement some mentoring program for LA-CoNGA, but we should continue these talks. We haven't had time to implement this, but it was great to talk to Paula and other people from AlphaCent.
Okay.
There is a question from outside. Luis, go ahead.
Melissa, thanks for your talk. I should speak Spanish because it's quite strange to speak Spanish, to speak English among people that knows Spanish. I have sent you the email, my email, because your university is part of our consortium of EL-BONGÓ, and I need help from your side, and you will have the opportunity to participate in at least 4 communities, one in seismology, one in high energy physics, which is your expertise, another one in space weather astrophysics, and another one in high performance computing and artificial intelligence. Please contact me ASAP, because we need help that your university has to sign some paper, and we have a lot of problems.
Oh, of course. I will send you an email. But just wondering if you already sent an email to the university, because I was not aware.
No. I'm in contact with your dean, Brian Larios, but it doesn't work. It doesn't work.
I know. Okay. I will do the connection.
As simple as that.
Okay. Thanks a lot for letting me know. I will do. Thanks a lot.
Okay. Thanks a lot.
More comments, questions? If not, I'd like to thank Melissa again. And Rogerio is gonna give some final words. Thank you, everyone.
Okay, so it was a long symposium, but I think we really got together. It was very nice and see the development in this field of high energy cosmology and astroparticle physics in these 4 years since the first strategic planning. So it was really great to have all these talks that really brought together all these efforts in the region. It was really amazing, and also putting people together that like just happened with Luis and Melissa. You know, this is one of the goals of this type of effort. So it was really great. So on behalf of the organizers of this symposium, so Diana Lopez Nasir, Marta Losada, Fernando Quevedo, myself, I want to thank you, all the participants online, and especially the ones that came here in presence, which was really great to have coffee breaks together and talk, and this was fantastic. And yeah, so the next steps is to collect this material, and the preparatory group of LASTRI is going to work on it to make an update of the physics briefing book and then of the strategy document. So we'll let you know what's happening in the next steps. So thank you all for coming and participating online. Thank you. Now we have coffee.